Welcome and thanks for joining us. My guests today are Nick Perez, the Chief Technology Officer for Cloud Practice at Thundercat Technologies, and Al Ford, the Artificial Intelligence Alliances Manager at Dell Technologies. Good to have you both with us. And our topic today is how you bring your infrastructure, your hybrid cloud approach to data processing in general, and marry it with AI and AI special requirements and AI data, which also is a big requirement. And I think it's a good time to be talking about this because AI has moved from the experimental and is actually being incorporated into agency applications across the government. I just talked to the U.S. Patent and Trademark Office today. Their search function for their examiners now has an artificial intelligence back end. So we're seeing this go mainstream. And what I wanted to ask you gentlemen first was, what are you seeing across the government in the way agencies are approaching marrying these two things, AI data, and their infrastructures? And what do you think the best practices are in that regard? Nick, why don't we start with you?
Absolutely. Thank you. Yeah, so we're definitely seeing traditional customers have been doing this on premise with, expensive equipment in high performance computing environments and bringing a lot of tooling. The opportunity and one of the benefits of the cloud is that they can, leverage the compute and the power that's available inside these cloud providers and move your data and then absolutely maximize the compute power there and the tooling. So different cloud providers provide different tooling. Some of them you're a lot more hands-on yourself, and some others have a lot more of them, particularly the models that you can absolutely use. But text analytics, speech, video, we're seeing a lot of that those kind of translation and then performing AI on those. After the situation we've had over the last 13 months, there's been a big land rush of moving to the cloud and, a lot more accelerated than it was previously, I would say, certainly in the federal space. And leveraging those technologies are there, being able to do things, faster and more reliant, and ultimately in a cheaper cost, because you can ultimately turn off those particular workloads once they're complete.
All right, Al, what are you seeing?
No, absolutely. Very similar to what Nick's sharing and talking about. And then as you start to incorporate artificial intelligence into those techniques, right? So people have been moving to cloud for the last 10 to 15 years. But with artificial intelligence, you have to consider newer infrastructure for specifically accelerators within these environments. And so it's an added challenge. And then it becomes, okay, am I running that in the cloud? What locations, et cetera? And as Nick mentioned, how do we take this from on-prem into those environments, because it's moving to the edge? So we're seeing a lot of converged or hyper-converged infrastructures being set up. It's easy. It's a little bit more easy to deploy, and then add your software stacks that can burst to the cloud locations as well as to the edge where artificial intelligence is occurring.
So the edge could be the agency's own resources as opposed to a commercial cloud.
Yes, sir. Edge really is a very broad term, almost like cloud was 15 years ago. Edge can be at a given remote location. It could be that you're part of the geological survey and you've got a vehicle carrying a camera and you need to access that vehicle. So the edge literally could be out field deployed.
I was going to say, yes, aircraft even have pretty high performance boxes that you can load on and take with you and aboard ships and so forth that operate in sometimes environments that you may not be able to have a mainframe, but we're getting mainframe grade computing in those locations, in other words.
Correct. Absolutely.
If I would add there, if I can add there, Tom, I would say is a lot of it is also processing, particularly like on a camera. So on a camera, edge processing there. So performing AI, where the image or whether the video is being captured, performing detection and analysis and awareness, whether that's a person, that's an animal, typically, and then only relaying the data that's being captured and that's been analyzed, moving that to the cloud and or in theater, putting equipment in the back of Humvees and equipment and performing processing right there instead of capturing it, sending it somewhere else for analysis, and just making those decisions much, much faster.
And Al, you mentioned accelerators. Maybe just talk briefly more about what that means and how they apply in this whole wherever and anywhere computing type of setup.
Absolutely. So accelerators are CPUs, central processing units. GPUs are very popular today, graphic processing units. And then they're building out a whole practice around these accelerators. So there are field programmable gate arrays that a lot of people in the Department of Defense have been using for quite some time. So one of the areas that our Dell Technologies Office of the CTO has called out is you really need specialists in the IT organizations to identify what accelerators are needed for those environments. So that's what really helps when you've got organizations like Thundercat and Dell working together, is identifying the right accelerator for these types of workloads.
And on the topic of hyper-converged infrastructures and virtual machines doing all of this, then can they move from those workloads? Can they move from cloud to, say, edge device and back and forth agnostically, without having to worry about interfaces and so forth? And that is to say, can the hybrid environment operate as one big logical environment, and you can do what you need to do where you need to do it with those hyper-converged setups?
Yeah, we have customers doing that today on multiple different cloud providers outside the United States and within the United States, and bringing that content back for processing, whether it being on-premise in their own location or Thundercat helping them with co-location and equipment in cages and in private racks.
Yeah, and to add to that, some of the benefits of that hyperconverged is the infrastructure is already there. So you're taking the compute, the networking, and the storage. It's all available and served up into these containers. And it's those containers that are delivered to all those locations Nick mentioned that you can incorporate all of the analytics inside of and deliver that out to the edge or to an off-prem location or to a cloud provider.
Yeah.
And go ahead.
I was going to say, the beauty of it is you're using the same equipment, the same technology, the same education and investment you've had for obviously a number of years. You're just now moving it to the next stage and being able to do it faster and quicker.
And with respect to artificial intelligence, what are the special demands of those types of projects? And then perhaps running them as finished applications. Do they make special demands on the computing setup, on the architecture, and on the approach an agency might take?
Yeah, very much as Al said, the GPU is really, utilizing those latest and greatest kind of flash arrays and those latest and greatest GPUs available for high speed. So high speed is the critical element of it. We see a lot of people using these cryptocurrencies and they're creating hashes, and that's kind of formulating a lot of the AI processes that are coming out. It's the rapid speed of being able to process this stuff, make the determination like a rules engine, and move on to the next piece of the workload to figure out, what the deltas is. Positive, fake positives. You're trying to do this analysis constantly and train the models. So yeah, it's ultimately, high speed, but consistency.
Yeah. And just to add a little bit to that, you typically with artificial intelligence, particularly within machine learning, you have two different, cycles you need to run through. The first cycle is working with the training a model. So you've got a lot of data. You've got to train the model what to look for. Once you have that model, you create an inferencing engine. That inferencing engine is what you send out to the edge to look at the real-time video feed to determine if you can find what you're looking for. So the accelerators are very important in that area, right? Because you have to have the right accelerator for each of those given cycles involved in the machine learning and artificial intelligence process. So again, it brings it back to those accelerators, and then working just on top of that hyper-converged infrastructure, you really build from the ground up to meet that mission outcome.
And there's a cost implication there too. If you are doing your training part of the ML cycle and you have a data set, which the bigger the better in some ways for training algorithms, that then could all take place within the commercial cloud part of your architecture. That way the data stays there and you don't have data extraction costs, which agencies are always worrying about. Whereas the deployment then can take place at the edge using data at the edge and not pulled down from the cloud. Is that a fair way to look at it?
That's a great use case. I mean, that is the primary use case of what's going on, and you nailed it.
Okay, yep. Any examples you can think of?
Yeah, well, let me expand on that if you don't mind. So what we've seen a lot of time is data has to come from those sensors or the edge in an IoT type of environment, or perhaps even a different remote location that could be in a building. And most organizations have to bring the data back to a centralized location before they can analyze it. So that's known as a centralized environment. And so, Tom, what you're kind of getting into is the ability to provide federated learning or training capabilities. And Nick and I discussed this But effectively, federated is, rather than bringing the data from the edge back to you, why not send those analytics in that virtualized container to the edge so that you're not moving the data? And then once you have the results computed at the edge, you only send back the results. So to your point, Tom, you're lowering the bandwidth, and you're also decreasing the amount of data that has to traverse all of those networking hops back to your initiator who's doing those analytics.
And to draw it one step further, if the IoT and sensor data that you gathered to actually execute against the trained algorithm makes you decide, golly, that data should be part of our next round of training, for example,
Right.
then at some time when it's cheap and easy, late at night or whatever the case might be, you could move that data to the cloud. But again, a one-way move. It's better to move data to the cloud than from the cloud.
Absolutely, yeah. You could even move that to like a low-speed queue. You could actually, move those items and say, all right, we're going to retrain the model. We're going to constantly move. Something new happened here. We're going to analyze that, and we're going to train the model on how to detect those particular pieces and or insert some other processes in place. Absolutely.
I guess if you have a co-located caged facility, I guess you could send those people a disk or a thumb drive, and they could load it up. That would even save a lot of money.
Absolutely. Yeah.
Right. And to take it a step further, the other thing, we're now looking at data in two distinct ways. Number one, is that data immediately actionable? Or number two, is it historically valuable? If it's immediately actionable, we want to apply that data immediately to one of the accelerators at the edge. If it's just historically valuable, then perhaps we go ahead, to your point, send it back to a cloud service provider or to a colo location, and keep that data because it's still relevant and important. However,
yeah, we had a use case for a long time ago with the genome. The genome is a very, very large process. Typically, you work on a very, very small subset of it. Like we are less than, what was it? Each of us is less than 1% actually different from each other. So you're physically leveraging or analyzing 1% of the genome, but you learn new things. These researchers learn new models, and or we have, a global pandemic or Ebola or whatever the thing is happening at the time that changes the processing. And we need to go back. We need to go back to that particular original genome, pull out a new subset and process it. But we're not processing the whole thing. We're processing a nugget of information or reanalyzing it because we've learned something new.
All right. Yes, I've been told I have as much in common with the earthworm as with the rest of humanity on that project. We'll take a break on that note. My guests today are Nick Perez, the Chief Technology Officer for Cloud Practice at Thundercat Technology, and Al Ford is the Artificial Intelligence Alliances Manager at Dell Technologies. I'm Tom Temin. This is Federal Insights. Our topic is a hybrid cloud approach to managing AI and AI data, sponsored by Thundercat Technology and Dell Technologies here at Federal News Network.